Okay, welcome back everyone. In this video we're going to be looking at a two-dimensional kinematics example, so projectiles, and this is number 47 from chapter 3. And so the situation is we have a ramp that's 200 meters long and angled at 35 degrees, and our object has an acceleration of 1.25 meters per second until it reaches the end of the incline. Then it becomes a projectile. And so what we're trying to find is the maximum height and the range that it travels. So both of those measured from this 0 point P right here. Okay, so let's think about what happens. In order to find the maximum height, we're going to need to know the speed that it leaves the ramp with. So we could call that V initial. Or if you like, call this point Q. This would be the speed at Q. Okay? Then it's going to go in a parabola, as projectiles do, and reach its maximum height at point R, at which point it will have horizontal velocity but not vertical. So Vy at R is equal to 0. So that's going to help us immensely. And then we'll solve part B after that. So the first thing we need to do is figure out how fast it's going at the end of the incline. And we're going to use the forgotten equation again, which, as I mentioned in the previous video, is that our final velocity squared is equal to initial velocity squared plus 2 times acceleration times displacement. Now, I didn't mention this last time, but this is very important. This equation is only valid if the acceleration is constant. So if the acceleration is changing as a function of time, which does happen in this course, and you probably have already seen that, if the acceleration is changing, this equation is not valid. So you have to be very careful. Okay, so we can cross out the initial velocity at point P. We're starting from rest, and so we can solve for the velocity at point Q. We have an acceleration of 1.25 meters per second squared, and we have a distance of 200 meters. That's squared, and all of this gives us a velocity at Q of about 22.4 meters per second. Okay, so that's review. That's things that we did last chapter. So now, here's where the projectiles come in. We have a velocity, VQ, which is at an angle of 35 degrees, because that's what the ramp is, and so we must decompose that into VQX and VQY. Okay, so VQX is going to be VQ cosine 35 degrees, and that's going to be about 18.3. Similarly, we can write VQY is going to be VQ sine of 35 degrees, and that's going to be about 12.9 meters per second. Okay, now in order to get the maximum height, we observe that VQR is going to be 0 in the y direction. Whoops. Sorry, let me try that again. VRY is going to be 0. So in other words, the vertical speed at the top of our path will be 0. I wrote those backwards, sorry. Okay. And so what we can do with this is use our velocity equation that says VYR is equal to VYQ plus AT. Okay, well, that would be lovely if we knew what the time was to get to the top. So instead of doing that, we're going to use that forgotten equation again, and we'll say VYR squared equals VY vq squared plus 2a delta y. And in this case, a is actually gravity. Okay, so this goes to 0, and we know that this vqy is 12.9, and it's positive. And then we have plus 2, negative 9.8 for g, and then delta y is what we wish to find. And plugging everything in, we find that it's about 8.42 meters. Now, that's not the maximum height that we reach, because the ramp itself is 200 meters long at an angle of 35, giving us 200 sine 35, or 114 thereabouts, 114.7 if you want to be exact. And so the actual maximum height is going to be 114.7 plus 8.4, and we're just going to round that to about 123 meters. So that's your answer for part A. Now for part B, we want the range. And the range is, if we look at the path starting at the top all the way over to here, the range is the total x distance that we've traveled. And again, we'll have to add in x initial, which will be 200 cosine of 35. So now we're going to need to find out the time that we're in the air, because we'll calculate delta x as x naught plus vqx times t. So the second term represents the motion forward based off of our horizontal velocity. The first term is just the x length of the ramp. Okay, so we already know that vqx is 18.3. What we don't know is the time. So we go to our y equation. Y final equals y initial plus vy initial times t plus 1/2 gt squared. And we're going to choose as our 2 points to apply this equation to. We will take point Q at the top of the ramp and then point S when it hits the ground. So that means that ys is equal to yq plus vyq. Okay? And we already know what all of these are. So the height at the ground is 0. The height that we start with is 114.7. The initial velocity is positive, and it's actually 12.9. And then we have our gravity term. Okay, so at this point, again, I would use Wolfram Alpha, or just pop this into a calculator, and I would solve this for the time, and I'm going to get 6.32 seconds. So that means that my total distance traveled is x naught, 200 cosine 35 degrees, plus vqx, 18.3, times time. And again, I'm just plugging in to this equation. And so what that gets me for my final answer is about 280 meters. Okay, so you can see that there's quite a lot of detail with these projectile problems, and the key is correctly labeling all of your variables. And the other thing to be very careful about is if you're dealing with a situation where you have a non-constant acceleration, then you actually have to go through and derive all the equations. You can't use the kinematics equations that we learned in Chapter 2. So you just have to think about it and be careful.